So here we're going to look at some of the features of solubility, including the language and some of the quantitative ideas with solubility. So quantitative, remember, uses numbers, and the quantitative description of solubility, let me just write down quantitative description, is right here. Okay, so let's just look at it. Quantitative means number. So it says solubility is the amount of a solute that will dissolve in a specific amount of solvent at a given temperature. And then right underneath it, I have an example. So let's connect the definition with the example. So it says the amount of the solute. So solute is what we're dissolving. In this case, it's a solid into water, which is a liquid. So the amount of the solute is here. And this is really the maximum. Sometimes this is called the solubility limit, right? Because it's the maximum that will dissolve. So 27 grams of KBr, potassium bromide, will dissolve, and it says dissolves in a specific amount of solvent. So we have a specific amount of solvent. So in our example, it's 100 grams of water. And water is 1 gram per milliliter. Oops, I don't want to have to put an X out of it. Sometimes this will be milliliters because 1 gram of water is 1 milliliter. And then it tells us finally in the definition that it is at a given temperature. And so in this particular case, it's at 23 degrees Celsius. And on the next slide, we'll investigate a little bit more about why they would have to include the temperature in the solubility or the solubility limit. Now, we don't have to memorize these numbers. These are things when we have to solve problems, they will give us. I suppose if you were really working somewhere, you might have to look up things. There's books of these kind of information. But we just need to understand that solubility for the different chemicals will have different amounts maximum that it can dissolve. And so for potassium bromide, anything less than 27, so from 0, so just above 0 all the way to 27, it will all dissolve in 100 milliliters of water. But if you added 28 grams of KBr into 100 milliliters, 27 would dissolve, but the last part would not be able to dissolve, and it would remain as a solid, and eventually, if you stop stirring, would settle to the bottom of the container. It's not because potassium bromide is not soluble, but it's because there's a limit, like a maximum that will dissolve. If you increased the amount of solvent, so if you went from 100 milliliters of water to 200, you could dissolve more solid. Now, in lab, you're not really going to be measuring when you're talking about solubility. You're going to use quantitative descriptions. And we've already investigated these words just a little bit. So if we're looking at solids mixing with liquids, we use the two words soluble if the solid will dissolve and insoluble if it will not. And then if we're mixing liquids, in liquids, we use slightly different language. So over here, liquids in liquids. If two liquids will mix, we use miscible. If two liquids will not mix, we use immiscible. So when you do the solubility experiment in lab, you will take several solutes. Most of them are solids, but you do have a liquid, and you'll mix them with different liquids. If the solid dissolves in the liquid, then you will say that it's soluble. You won't have to write down numbers. You'll just say it's soluble. If the solid does not dissolve in the liquid, you'll say it's insoluble. If your liquid dissolves in the liquid solvent, it would be miscible. If the liquid does not dissolve or does not mix, it would be immiscible. So in lab, we'll be using those qualitative descriptions. Well, let's investigate a little bit more about the idea of temperature impacting our solubility. So here's another graph, and we can see this particular one. There's 4 lines on it. I see one for sodium chloride, potassium chloride, lithium chloride, and that looks like sucrose on the top, the purple one. So as we compare what this chart's looking at, let's look at our axis, because when you get charts, you have to kind of investigate what they're telling you. So along the x-axis, we have the temperature, and I see that it's increasing from here to here. So it goes from 0 to 100 degrees, and it's in water, so it goes from freezing to boiling. And then along the y-axis, it's the solubility, so how much will dissolve in that water. Now, notice it's not all equal. They don't all have the same, but in general, they have a directly proportional relationship, meaning that as you increase the temperature, the solubility increases. And you see it here. The solutes are more soluble. Their solubility increases as the temperature increases. Now, they're not equal, like some increase more than others, but it's just a general statement. If we heat it up, our solubility will be higher. That's why on the previous page, they had to tell us 23 degrees, because the number, the 27 grams, would change if the temperature changed. So let's just pick one. Let's pick sucrose, which is the top purple line, and let's investigate it a little. So let's say I am at, 5, 10, 15, 20. Okay, so these look like they're going with 5. So let's go at 10 degrees Celsius. So it goes to right there. So for the C12H22O11, at 10 degrees Celsius, it looks like, 50, 60, 70, 80, 90, about 95 grams of it in, that would be 100 grams of water. So about 95 grams of sucrose. Well, let's warm it up. And let's go up to 50 degrees. It's just above that line. I'm not drawing very straight. So let's see, 100, 110, 20, 30. So it's just like, so at 50 degrees, it's like 130. Oops, I want to say 2. It's just over the line. I'm messy. In 100 grams of water. So notice the solubility, which is this, increased as we increased the temperature. And so that's just an effect of these solid solutes. Now, remember, in a previous one, we talked about gases, and gases have an inverse relationship with temperature. Their solubility actually decreases as you increase temperature. But solids, their solubility increases as you increase temperature. I do find it interesting, before I go to the next slide, just looking at sodium chloride. Notice that sodium chloride, which is table salt, it just hardly at all increases the solubility as you increase temperature. It's barely raising. So temperature doesn't have a huge impact on the solubility of the sodium chloride. Different solids will have variations in that. Okay, now I just thought of another thing. If we were in class, I know I would mention it. Calcium carbonate, it has the opposite. Its solubility decreases. This is kind of an exception. And I'll tell you why I'm telling you that with increasing temperature. This is just an exception, and you don't have to memorize this. I just want you to know. So calcium carbonate is one of the things we find in hard water. And if you've ever had any plumbing done, or you've seen things like any lines, and I noticed this first in our dishwasher, you can have this white fine powder in your pipes. What happens is, or in your hot water heater, it can settle to the bottom. So hard water has calcium carbonate as a part of it. And when you heat calcium carbonate, it becomes less soluble. So the harder your water, you can get a precipitate out of this calcium carbonate in hot solutions. So sometimes they flush your hot water heater and there'll be all this kind of white powder. That's calcium carbonate, because as in the hot water heater, the solubility is less. So I just mention it not so you memorize it, but just to know that while we do have a lot, most solids increase solubility with temperature, there are those ones, and they might even impact your daily life, that their solubility decreases with temperature. And calcium carbonate's one of it. And we recently had to have our hot water heater flushed, and I saw that white powder, and it made me think of this. So that's just a little fun extra aside. So let's talk about how we describe solutions in relationship to their solubility. So here's the first two words, saturated and unsaturated. So when I think of the word saturated, personally, I think of something that is full. Like it's maxed out. And so then we know...
I didn't get that. Could you try again?
My watch isn't being too smart. So saturated is full, maxed out. If you put so this is going to be below full, less than full. Okay, so we know that there's a limit to how much can dissolve. And anything when you get to the limit, so if you are saturated, the solution, you aren't. If the solution is saturated, it contains the maximum amount of dissolved solute. Now, notice they write here at a given temperature. Why? Because we know the limit changes with temperature. So if the limit changes, we have to know what temperature it is to know what the maximum is. So in the previous example, when we have 27 grams of potassium bromide in 100 milliliters of water, 27 is the max. If I have 27 grams dissolved, my solution is saturated. If I have 30 grams dissolved, my solution is saturated. The difference is some of it will settle to the bottom, right? Because it can't all dissolve. It's saturated. Now, unsaturated is below full. So if you're below full, you're less than full, you're going to have less than the maximum. And in this case, all of the solid dissolves. Okay, so we won't have anything extra. You haven't reached the maximum yet. I can come up here and then add a little bit. I mentioned it, but I can add it here. So up to the maximum, it all dissolves. Over the maximum, the extra settles to the bottom. Like it won't dissolve. Okay, so the solute keeps trying to dissolve it, but if it dissolves some of the undissolved, it would just precipitate out some in there. Like it can only go up to the maximum. So there's one other kind of solution. So most commonly we'll encounter saturated and unsaturated. But there is one other special kind of solution that I think of as being tricked. And this is something called supersaturated. This is rarely the answer in problems because this takes a lot of work. So the definition, if you're super, you're above saturated. But here's the trick about it. You're above saturated, but the trick is all the solid remains dissolved. And you might be thinking, what? Okay, in a saturated solution, you get to the maximum, and anything you add over the maximum cannot dissolve, so it settles to the bottom, right? Saturated means you're maxed out, and if you go above it, it will just settle. Supersaturated means you have created a solution that you are able to go above the limit and keep everything dissolved. Okay, this is a tricked solution, and so this is the trick. They have it right here for us all to see, right here. It requires heating. So what you do is you heat the solution, and as you heat, it allows more to dissolve. So you heat and you allow more to dissolve because your maximum is being raised as you heat it. But then what happens is you cool it. So upon cooling, the solution is supersaturated if all the solid remains dissolved. So the only way this is an answer, the only way a solution is supersaturated, is if you heat it up, which raises the limit, then you cool it carefully back down, and all of it stays dissolved. Then the result is a solution that contains more solute than needed to saturate it. You're above the saturation limit. These solutions are very unstable, and so often what happens if they're disturbed is that the extra solute precipitates out as a solid and it returns back to saturated. Okay, so again, let me distinguish. Supersaturated is rarely the answer. The only way to supersaturate a solution is by heating it to raise the limit and then cooling it. The only way that solution is supersaturated is if all the solid remains dissolved. If the solid precipitates out, it is saturated. So let's look at the bullet points. It says, let's look starting here. At 55 degrees, the solubility of sodium acetate is 100 grams per 100 grams of water. If a saturated solution, saturated at 55 is cooled to 20, and so here's the trick, and let me not highlight that. Saturated solution at 55 is cooled down to 20, and the solute remains dissolved, then you have a supersaturated solution. So you heat it, cool it, and the solute remains dissolved. If the extra solid precipitates out, now the solution is saturated. Extra solid will settle to the bottom. So you can see in this graph, here's the purple line here. That's the limit. So anything below the limit is unsaturated. If you're able to go above the limit, it is supersaturated, but it requires heating. I just can't emphasize this enough. It requires heating, and all the solid has to stay dissolved. Otherwise, you simply have a saturated solution, right? You can't just add above the limit and call it supersaturated. You have to add by heating and cooling, and then all the solid stays dissolved. Okay, so supersaturated is rarely the answer. So I have a practice question to try to put some of these numbers to use. So it says 34 grams of potassium chloride will dissolve in 100 grams of H2O at 20 degrees. So what this sentence right here is, this is our solubility. There's no question here. This is just information. Like how much of my solute will dissolve at what temperature. So then it says, will a solution prepared by adding 32 grams of KCl to 100 grams be saturated or unsaturated at 20? So we do notice that they're both at the same temperature. So let's see. This has 32 in 100. The limit has 34 in 100. So we are below the limit. If you add less solute than the limit, your solution is unsaturated. If a solution is unsaturated, your observation will be that all the solid dissolves. Okay, so if it's below the limit, it would be unsaturated. We would add it, all the solid would dissolve. Let's look at the second question. Will a solution prepared by adding 18 grams, okay. Let me see, I have 18 grams of KCl. Oh, at 50 grams of water. We're still at 20 degrees, so it still works. Okay, so if we have 50 grams of water, that's half of 100. So if 34 will go into 100, then only 17 will be in 50, right? If we cut the water in half and they don't give us any more information at the same temperature, it will dissolve only half. So now I compare 17 is what I can dissolve in 50, but I'm trying to put 18 in. So I'm trying to add more than the limit. So this would be above the limit, right? Because I only can do 17 in 50. And if I add above the limit, that is going to create a saturated solution. It's not supersaturated because I didn't heat it and cool it and do anything. I just added it. Now, what would I observe? Well, I would observe that 17 grams dissolves and about the 1 gram that remains as a solid. And the water will keep trying to dissolve it, but when it dissolves the solid, it will just cause another part to precipitate out. So to my eyes, even though the water keeps trying to dissolve it, to my eyes, it's going to look like nothing's happening. It's going to look like I dissolved most of it, but there'll be a little bit left just sitting at the bottom.